Hi, I'm Elisa delaRosa, and I will discuss Module 6 to 8. In medium access protocols, there are two groups of networks, the point-to-point and broadcast, or multi-access. In point-to-point, to send a packet from station to station, the packet needs to be stored to a station until it reaches its final destination. Because of the storing and then forwarding manner of communication, this type is termed as store and forward. In broadcast or multi-access, the packet is sent from station to its final destination by simply broadcasting the whole packet in a single shared channel. All stations connected to it can hear the packet, but the only intended destination would fetch the packet from the medium. There are four types of multi-access protocols. First is fixed assignment. It attempts to allocate the channel in a static fashion which is independent of the activity of the station. Here we have FDMA, TDMA, and CDMA. Frequency division multiple access gives users an individual allocation of one or several frequency bands or channels. It is particularly commonplace in satellite communication. The time domain multiple access allows several users to share the same frequency channel by dividing the signal into different time slots. The users transmit in rapid succession, one after the other, each using its own time slot. For code division multiple access, several transmitters can send information simultaneously over a single communications channel. In theory, these three, CDMA, TDMA, and FDMA, has its own challenges. Power control for CDMA, timing for TDMA, and frequency generation filtering for FDMA. The second is random access. Random access channel is allotted to the needing stations randomly. We have pure aloha and slotted aloha that works for this one. Pure aloha uses a carrier sensing scheme, or what we call carrier sense multiple access. It determines whether another transmission is in progress before initiating a transmission. It allows the terminal to transmit a packet anytime there is a packet to send. When a collision condition is detected, station stops transmitting and waits for a random time interval before trying to resend. In slotted aloha, stations transmit frames at the beginning of time slot. The third is demand assignment. In this, channel is allocated based on the need of the station contending for the channel, so it is important that the station announce their requirements. For central control, it requires the use of a central controller to allocate the channel to a requesting machine, and central control is classified as polling system and circuit-oriented system. In distributed control, it has many different kinds. Among them are reservation aloha, that is good for networks with a known number of stations and uses slotted aloha. Round robin reservation scheme that has a fixed TDMA assignment of station to slot. An FIFO reservation scheme where reservations are made explicitly by the station. Adaptive strategies and mixed mode or mixed strategies are commonly applied to satellite systems that uses slotted aloha for uplink and TDMA for downlink. Reservation upon collision, where stations are accessed the channel like slotted aloha, but when a collision is encountered, the channel is allocated based on the reservation made by the colliding station. Moving forward to land standards, we have two, like 802.3 CSMA for one, which is a standard specification for Ethernet, a method of physical communication in a local area network. In general, this specifies the physical media and the working characteristics of Ethernet. You will notice in the type of cable that all starts in 10. The 10 in the media type designation refers to the transmission speed of 10 Mbps. The base refers to the baseband signaling, which means that only Ethernet signals are carried on the medium. We have here 10 base 2 that has thin wire coaxial cable, 10 base 5 thick wire coaxial cable, optical fiber for 10 base F, and so on. This is actually the part of the 802.3 frame. They say every frame starts with a 7-byte preamble. It has start of frame delimiter, destination address that specifies the intended station of the frame, source address that identifies the station that sent the frame, length field, logical link control headers, the data unit of the frame, and path that are actually added to ensure the frame is long enough for proper collision detection. And lastly, the frame check sequence with the 32-bit CRC based on all parts of the frame. The second is 802.5 or token ring. In this, medium is configured similar to a bus, except that both endpoints are connected to form a loop. A token is a beat pattern that circulates the ring whenever all stations are idle. When station wants to transmit a frame, it seizes the token by changing a single bit in the token. Only the source station can remove the frame of the ring in 802.5. The station cannot remove the frame, but it can modify some bits which serves as an acknowledgement for the source station. The information frame circulates the ring until it reaches the intended destination station. The information frame continues to circle the ring and is finally removed when it reaches the sending station. Now this is actually part of 802.5 frame. Basically, the frame follows a format of 802.3. It also has some destination address and source address and frame check sequence. For the other fields, it contains information like bit to inform the source that it was able to recognize its address or was able to copy the frame. Now for network layer in Internet Protocol. Network layer deals with delivering packets from source to destination through multiple hops. It is the lowest layer that deals with end-to-end communication. On its sending side, it encapsulates segments to datagrams. On receiving side, it delivers segments to transport layer. It is concerned with controlling the operation of the subnet, that is routing the packets, again, from source to destination. Routes can be based either on static or dynamic routing tables. Its two functions like forwarding and routing. Forwarding moves packets from router's input to appropriate router output. In routing, it determines route taken by packets from source to destination. In network layer, there are like routing algorithms that are grouped into two, non-adaptive algorithm and adaptive algorithms. On the first one, it does not base the routing decisions on measurements or estimates of the current traffic and topology. Instead, choice of the route to use to get from source to destination is computed in advance, offline and downloaded to the routers when the network is booted. This is sometimes called static routing. The second one, which is adaptive algorithms, change the routing decisions to reflect changes in the topology and with the traffic as well. It is also called dynamic routing. We have samples like shortest path routing or distance vector routing. The idea of the first is to build a graph of the subnet with each node of the graph representing a router and each arc representing a communication line or link. In general case, the labels on the arcs could be computed as a function of the distance, bandwidth, measured delay, and other factors. In distance vector routing, the concept is each router must have a routing table which contains the best computed distance to each destination and the path to use in order to get there. And it also requires that the router inform its neighbors of topology changes periodically. The inter-networking, it is the practice of connecting a computer network with other networks through the use of gateways that provide a common method of routing information packets between the networks. Some of the devices that can be used for inter-networking are bridge, repeater, or router. The bridge is a computer networking device that creates a single aggregate network for multiple communication networks or network segments. This function is called network bridging. Bridging is distinct from routing, which allows multiple different networks to communicate independently while remaining separate. Repeater is an electronic device that receives a signal and retransmits it. Repeaters are used to extend transmission so that the signal can cover longer distances or be received on the other side of an abstraction. For the router, its main purpose is to connect multiple networks and forward packets distinct either for its own networks or other networks. A router is considered a layer 3 device because its primary forwarding decision is based on the information in the layer 3 IP packet, specifically the destination IP address. The Internet Protocol or IP is responsible for addressing hosts and for routing datagrams from a source host to a destination host across one or more IP networks. The Internet Protocol defines the basic unit of data transfer as IP datagram. Basically, IP includes a set of rules that process the idea of unreliable packet delivery, like how hosts and routers should process packets, how and when error messages should be generated, or even the conditions under which packets can be discarded. IP address is a unique global address for a network interface. For an IP address to function, there must be properly configured IP address and compatible subnet mask. Otherwise, an IP conflict will occur when two devices have been assigned the same IP address, and all of these devices will have problems sending and receiving data. Lastly, subnetting, and it enables the network administrator to further divide the host part of the address into two or more subnets. Sub-network addresses are derived by using a subnet mask, and these are not an IP address at all. Thank you.